All right, guys. We actually have a lot to cover today. A lot to cover. We're doing both segments and angles in a circle. Normally, I teach these two concepts on 2 separate days, but we don't have time for that. So we're squeezing them all into one. So we're going to do segments, and then we're going to practice on whiteboards, and then we'll do angles, and we'll practice again. Now, what is a segment? Well, yeah, it's like a part of a line. Good. Now, there are 4 different types of segments in circles that you'll come across. And yes, you'll have to remember these equations, okay? The first one, so open up to your first flap, is 2 chords. Now, based on this picture, what do you think a chord is? Yes, a line, a segment that goes from one side of the circle to the other. Is it necessarily through the center? No, it's not. Now, here we have 2 chords intersecting. Whenever we have 2 chords intersecting, we use what is called the PP rule. Part times part equals part times part. So here we have A times B, so that's one side of the chord times the other side of the chord equals C times D. So that's again the other chord, but this time C times, times D. So if I take one chord, multiply its parts, and set it equal to the other chord's parts multiplied together, I can solve for variables. This will work on any chords that you see intersecting in a circle. So up here, let's do this example. What type of segments in a circle do we have here? Wow, lunch has not invigorated us, huh? Okay. Trajan, what type of segments are these? Look right below it. Look low, below.
2 chords.
Ah, yes, they are 2 chords. Yes. So let's go ahead and solve it. Whenever we have 2 chords, we use the part times part equals part times part. P times P equals P times P. So give me one of the parts on any of the chords. Doesn't matter what we start with.
3.
Sure. 3 times, what's the other side of that? Same chord. Yes, X. Equals, yes, 9 times, the last part is 5. And then it's just a solving equations problem. So 3 times X is 3X. 9 times 5 is 45. Divide by 3, and what is X? And I'm done. That's it. Yeah.
Why does that work?
You know, that's a good question. It has something to do with the properties of a circle and the ratios of lines in a circle. All right. Now on to 2 tangents. Looking at this picture, how would you describe a tangent?
A line connected to a circle.
Yeah. How many times does a tangent touch a circle? A single tangent touches a circle in one spot. That's what makes it a tangent. Okay? It like approaches the circle and then barely touches it and then moves on. This is a tangent. So here I have two tangents. Whenever we have two tangents intersecting outside of the circle, we use what is called the party hat rule. Now we call this the party hat rule because it kind of looks like a party hat. And in the party hat rule, the two sides of the party hat are the same length. They are congruent. So that's why we have part equals part here. The two sides of the party hat are congruent.
Oh, that's so funny. Wow.
Part E. Not gonna lie, I just like drawing the face. I think it's cute. All right. How many tangents do we have here? 3. There are 3 tangents. How many party hats are there? 3. Now, can we find all of the sides of the party hats? No, we can't possibly know what those are going to be, right? But what can we know? What can we immediately know the length of? Which party hat? The one that has a what value on it? 4, right? If this is 4, what's the other side of the party hat? 4. Then, because I know that is 4, what else can I find? I heard it, I think. How do I know that? Yes, the entire length of that entire tangent there is 12. If I take away 4, I'm left with 8. That means that this segment down here is 8 long. So what is x? And I'm done. That's it. These are not hard concepts, it's just a lot to remember. Over here, these values, you can't know them. Nope, no way to find it. All right. On to 2 secants. Looking at this picture, what do you think a secant is? It goes through a circle. Yes, it intersects a circle twice. Now, does it remain inside the circle? It also has portions that are outside of the circle. So here, whenever we have 2 secants intersecting outside of the circle, we use what is called the whoa-whoa rule, which is whole times outside equals whole times outside. The whoa-whoa rule. So on this top secant, which everyone say secant. Secant, good. On this top secant, what do you think the whole represents? The inside, you think? That's going to be the whole. The whole length. The entire length of the secant is our whole. What about the outside? Where do you think that is? Oh my gosh, it's outside of the circle. Good. And then what about the hole on the bottom? What does the hole on the bottom represent? It's the whole length on the bottom, right? And what is the outside on the bottom? Where's that? Outside, good. So, let's try it up here. What type of segments in a circle do we have here? What type? They are secants, so we use the what rule? Whoa, whoa. Whole times outside equals whole times outside. What is the whole on that top secant? And what is the outside on that top secant? And what's the whole on the bottom?
12.
How did you get 12? You have to get, yes, you have to add the entire length. So that is our whole. And what's the outside? So 3 times x is 3x. 12 times 4 is 48. Divided by 3, what is x? Wonderful. Any questions there? What do you think the most missed part of this problem is going to be? This type of problem? Knowing to add the whole. Okay. So here, what do you think our first step's going to be? Yeah, label the values. So AE is 20. From C to E is 5. And from A to B is 12. Find DC. So what am I going to put on DC? An X. Good. Now I have two types of segments here? Secant. So what rule do I use? The whoa rule. Now what's my whole on the top? 20. And what's my outside on the top? How did you get that? 20 minus 12 gives us 8. So that's our outside there. And what's our whole on the bottom? Yeah, it's this entire length which we must add. X plus 5 is our outside whole, sorry. And what's our outside value? And now we just solve. So 20 times 8 is? Good. What do I have to do on that right-hand side? Distribute the 5. So I have 5x, then what? Plus 5, right?
Wait, why are you multiplying by 5? Wait. Also, you also multiply 5 by 5, so wouldn't that be 25?
Yes.
Right, that's the, why am I multiplying by 5, you ask?
Yeah, also, why are you multiplying by 5?
That's the outside value.
Whoa.
That's the outside of the whoa, right? So you do whole times outside. Now, the most missed part of this is that people forget to distribute that 5 to both the x and the 5. You would think you would know at this point, but you forget. So be very cognizant here that you're distributing to both the x and the 5. So 5 times 5 is?
25.
Good. Subtract 25 over, and we have 135. And then we divide by 5, and what do we get?
27.
An amount.
Why couldn't you just do it like, why couldn't you just do 5x and then subtract 5 at the end? Or could you? Because that's what I did and I got the same thing.
Yes, you could.
Okay.
Yep. Any other questions? Yes.
How do you get x plus 5? Because in the other one, you didn't add like 3 and x.
But I did here to get the whole. See, on this top one, it gave me the whole length. It gave me x, right? On the bottom, did it give me the whole right off the bat? No, so that's why I had to add the two parts, 8 and 4. So same thing here, it didn't give me the whole, so I have to add x plus 5. Does that make sense? Okay. All right, so go ahead and we'll do our last one. One tangent, one secant. Now we've already learned what a tangent and a secant is. So sometimes they'll give us a single tangent and a single secant. Now when we have a tangent and a secant, I like to call it, we use the TWO rule. which is tangent squared is equal to the whole times the outside. Now, which one of these values is our tangent? Which one of the segments? Yes, the one that only touches the circle in one place. So that's our t up there. And then the bottom line is our secant. So our whole is the entire length. And our outside is the portion outside of the circle. So the tangent length squared is equal to the whole times the outside of the secant. It makes what? All right, so let's try it. What type of segments do we have here? Secant, good. Tangent is secant, so we use the TWO rule. T squared equals whole times outside. What is our tangent value?
12.
And what is our whole? And our outside? So it's going to be 16 times x, which is just 16x. And then 12 squared is 144. And we divide 144 by 16 and we get 9. All right. Last one, and then we'll do the whiteboards. So again, we have a tangent and a secant. So we do t squared equals whole times outside. Our tangent here is what? So I do 15 squared is equal to the whole, which in this case is what length? And then, what's our outside? So here, 15 squared is, and I have to distribute the 9, or if you would like, you could just divide both sides by 9 and get it out of the way. But we'll distribute. 9 times 4 is 36, 9 times 9 is 81, 225 minus 81 is 144. Divide by 36, and x is 4.
70.
Whoa, okay.
Wait, no. No. You use 36.
Yeah.
No. Oh, we do that. Oh, okay. Yeah, my mind was somewhere.
All right, so just like for segments, how we had 4 different relationships we had to memorize, angles also have 4 different relationships we have to memorize. Now, we will either have central angle, inscribed angle, inside angle, or outside angle. Where do you think a central angle is located? In the center. Where do you think an inside angle is located?
Inside.
Somewhere inside. Do you think it's in the center? No, because then that would be a central angle, right? What about an outside angle? Where's that going to be? Oh my gosh, on the outside. What about, now this one's trickier, an inscribed angle? It's inscribed.
It's like a triangle inside the.
It's like the angle, the like arc is like inside the angle.
It'll be
So all the points end in are points on the circle.
Yes, an inscribed angle is an angle in the side of the circle. So if we look here, this isn't shh. If we look here, this is an inscribed angle because the angle, the vertex, ends in the side of the circle, in the arc of the circle. Okay? So first, we're going to go over central angle. Again, central angles are located in the center of the circle. So this right here is my central angle. And the central angle is equal to the arc that it creates. So the rays or the vertex, or the segments that create the angle also create an arc on the edge of the circle. So this right here is the arc that the angle creates. So if the central angle is 100, what is the arc going to be? Oh my gosh, they're equal. Now, thinking about this, what is the only type of circle that this works on?
A regular shape.
All circles are regular. We went over it for one day last unit. All circles are closed. Ah, oh my gosh. All of these angle relationships only work on the unit circle, meaning the radius is 1. Now, next class, we're going to learn what to do when the radius is not 1. But for today, we can only use these on the unit circles. So, let's go ahead and solve this central angle problem. It says find the measure of ST. What do you think that little curved line above ST means? Arc. That is the symbol to designate an arc. So it says find the measure of arc ST.
60.
Ah, why is it 60? Oh, because we have a central angle of 60 that creates that arc. So if the angle is 60, the arc is also 60. Angle equals arc. So if the angle is 60, the arc is also 60. And don't forget your degree symbols.
Wait, what does that mean though?
So we just write
Why
down.
wouldn't it be degrees? Like 60 degrees of what?
The arc.
Like, wait.
As the
what is that
unit,
measuring?
as the unit, the length of the curve in degrees. Yes. Okay. Now, inscribed angle. Again, where is an inscribed angle located? In the, now don't just say inside the circle, say in the side of the circle, right? In the side. Inscribed is in the side. So this here is our inscribed angle. And this is the arc it creates across from it. The formula we use is the angle is equal to 1/2 the arc. So if the arc is 50, what will the angle be? 25, good. Yes, all we do if we're given the arc is divide it in half to get the angle. And then if the angle is 100 degrees, what is the arc? 200, good, you got it. So up here, we're given an inscribed angle of 63 and it says find the measure of arc RT. What do we do here? Yeah, so the angle is equal to 1/2 the arc. They give us the angle 63. So to solve for the arc, what is the same thing as dividing by 1/2? So we just multiply both sides by 2. 63 times 2 is?
26.
Good, degrees. 126 degrees. Because that is our unit of measure. It's exactly degrees because our radius is 1. All right. Now on to the a little bit, not much harder ones. inside angle is somewhere else inside the angle. Inside the circle. Now, inside angles have to be created by two intersecting lines. In this case, these are called two what lines? I heard it, I think. Two intersecting, what did we just learn these segments are called? Chords. They're chords, okay? So in this case, we have two intersecting chords creating how many inside angles are there? 4. Now, if I say that this is my inside angle, right there, that X, that inside angle is equal to 1/2 of the arc it creates plus the arc across from that arc. The angle is equal to 1/2 the arc plus the arc. So up here, what type of angle is that X we're trying to solve for? It's an inside angle, so I use which formula? Yes, which is? Good. What's our angle? What's the arc it creates? And what's the arc across from it? Times 1/2? Degrees. Whoops. Oh, Jesus, that's getting harder. Yes. All right. What do you think makes number 2 trickier? Oh, so instead of just boom right off the bat solving for X, what do you think we should solve for? What arcs do we have? The other two, right? So we can solve for the angle right next to X. This, we'll call it Y. Now, why would I be doing that? Solve for Y, and then what would I do? Ah, yes. X and Y together form what type of angle there? Oh, a supplementary angles. Yes, a straight angle. Yes.
Is this going to be on the sides?
Maybe. All right. So now what we're going to do is we're first going to solve for Y. The angle is equal to 1/2 the arc it creates, which is 55, plus the arc across from that arc, 75. 55 plus 75 is... what? 130. Times 1/2? Is that my answer? No. What do I now need to do? Ah, so X is going to be equal to 180 minus 65, which is 115. Any questions on that one? All right. Last type of angles are outside angles. It's almost the exact same concept as inside angles, except one, we're now outside of the circle. So when you have an angle created by two secants or tangents outside of the circle, this is called an outside angle. And in our equation, the outside angle is equal to 1/2 of the big arc minus the small arc. What do you think is the big arc it's referring to? Ah, the one way far away from it, created by the two rays or segments that create the angle. So this is our big arc. Oh, I should write big. And where's our small arc? The one that's closer, still created by the same lines. So if we do the big arc minus the small arc, multiply it by 1/2, we have our angle. So let's go ahead and solve. We have what type of angle here? Outside. So we use angle is equal to 1/2 of the big arc minus the small arc. What's our angle? And the big arc that it creates minus the small arc, which is x. Now there's two things I can do here. Either I can distribute, or what else can I do? I'm just going to go ahead and multiply by 2 to get rid of the 1/2. And we subtract 110 over, and we get -60. Now is x equal to -60? What is x actually equal to here? +60, because we divide by -1. So this is a +60 is x. Ready for the last one? I guess. So we have the angle, which is 71, is equal to 1/2 of, what's our big arc? That's what we're solving for, right? That's our x, minus the small, which is 71. What can I do to both sides to get rid of that 1/2? Oh, jeepers. Thank you. You're right. So it's x minus 106. And then I multiply both sides by 2 to get rid of the 1/2. So 2 times 71 is? Good. And then I add 106 over, and what is x?
I think it's 36.
What?
I think it's 36.
Think what's 36?
X is 36.
Why do you think x 36?
Oh wait, no, I can say that.
Okay. X is 248. Any questions on this?